My name is Andrella Lee, the BAZUKA Prophet. And in our previous video, we were talking about what we call naming of coordination compound. Now, today, we're working on the examples. Now, example one, as you can see right here on the board, is that remember the rule one states that if you are having a positive complex and a negative complex, the positive ions are first named before the negative. And if we check this bracket here, what you have in here is a positive complex, which you will name first before you move to the what now, to the negative. Now in doing so, you name the what now, you name the ligands first, and the ligands, they contain what we call the Greek prefixes, which are numbers. Now, so what do? We start from here. Then we start from, remember, ammonia comes before what? Water, which is amine comes before aqua. So then becomes triamine, triaqua. Now remember, the valency of chromium here, which is the central metal here, will be plus 3. You might wonder and ask me, how is it plus 3? Now, before you can be able to understand coordination compound, you should know what they call oxidation state. Remember that ammonia and H2, they are neutral molecule, so their valency is 0. So 0 times 3 will cancel out, 0 times 3 will cancel out, leaving you with a negative ion here, which is, remember that the valency of chlorine for chloride anion is -1. So -1 times 3 is -3. And when they cross the equality sign, they are equal to 0. Or simple, this 3 is coming from here. Just so here become triamine, triaqua, chromium, because it's a positive ion. So chromium 3. Then there the chloride. I hope it is very, very clear. Yes. Start with that. Triaqua, triamine, chromium 3. Because it's like the central metal here is a cation ion. Then we put the Roman figure, which is the state of this chromium in Roman figure, which will be in bracket, in parentheses. Now we move to the next one quickly. That's for 1. Now for 2, what do we do? So in naming for 2, the same rule also obey. Now what do we do? Amine comes before this one. So here becomes pentaamine, then chloro, then remember platinum, what now? Platinum 4, bromide. Now you might ask me, why is it platinum 4 and not platinum 3? Now remember that ammonia is a neutral molecule, so 0 times 5 is 0. Here is -1. So the valency of this chloride ion here is -1. So -1. Bromine 2 is also -3. So -3 -1 is not -4. So when it crosses the equality sign, it goes to what now? +4. That's why it's called pentaamine chloroplatinum 4 bromide. That is for number 2 now. Now in the case of number 3, we move here to number 3. The rule also obey. Now very simple. Now we start from here, the positive ligand, so the positive complex here. What do we go? Then we come dichloro, a neutral molecule, dichloro. Now I won't say diethylene diamine. Remember I told you that for a ligand that is didentate or polydentate, we use the word bis to represent 2, tris to represent 3. So in this case, there is 2, here become bis ethylene diamine, platinum 4 chloride, platinum 4 chloride, -1 times 2 -2 altogether is -4. The same thing here. They will move straight away to number 4 here. In the case of number 4 here, the same rule here. Very, very simple. Very, very simple. You name this side there before you move to this other side. So what do? They become trees die. Very simple. As trees die. Okay. Now trees ethylene diamine. Diamine cobalt. As cobalt what now? That's cobaltine sulfate. This is a negative, like a negative radical. So you name it, which will end in ATE. Move to number 5. Very simple. You get on number 5. Now, number 5 is not quite different. Remember, in this case here now, I'm having a positive ion with a negative what now? A negative complex. So you must name the positive first. The positive becomes potassium. As potassium. Hexa. This is hexa. Hexa cyanoferrate. What now? Why the ferrate now? Remember, I've told you because it is a negative ligand, like a negative central element. It will not end in ATE. And if you end in ATE, you must put the Roman numeral. So ferrate what now? It will be ferrate 2. How do I know? It's to calculate for the what now of the return state of this one. Remember, potassium is +1. +1 times 4 is 4. Plus, I'm looking for iron here, which is X. Now, the valency for cyanide, of course, Cn minus is plus bracket -1 times 6. Remember, times this 6 here. So equal to 0. So 4 plus x minus 6 equal to 0. So x is now equal to 6 minus 4. Give me +2. I hope it's less. So that's why it is +2. Move to number 6. The same idea too. Then become sodium. Sodium tetrachloro. Sodium tetrachloronickelate. Remember, it's nickel ordinarily, and because it's a negative complex to end in ATE. Nickelate. What now? Nickelate 2. The same rule also obey. That 2 times 1 is 2. Yeah, -4. So we move ahead quickly. Now, if I'm having that potassium is +1. So 1 times 2 is 2. Plus nickel X I'm looking for. Chloride ion is -1 times 4 equal to 0. So X is now equal to 4 minus 2 to give me +2. Is that clear? Now we move straight away to number 7. In the case of number 7, we follow the rule again. Alright. Now for the next one quickly, which is the number 7 here. Yeah, in naming number 7, very simple. So what do we go? We start from here. Here becomes what now? Remember, same like complexes here. So here becomes, so all of them here are just complexes. So here become what now? Diamine tetrachloroplatinum. What now? That's planting, that's 0, that's platinum 4. Number 8. And maybe this one is very, very simple. Here become pentacarbonate. That's pentacarbonate anion 0. Remember, here it's a positive complex. So here this carbon that you are seeing here is a neutral molecule, so it's having a charge of 0. So 0 times 5 is 0, so we just have ion 0. Number 9, which is the last on our list here, is simple. Now this one now involves a positive ion with a negative ligand. So we name it positive first. It becomes ammonia. That's ammonium. What now? Ammonium diaqua. Ammonium diaqua. Bis. Remember, this one is the other and it's die here. It's die. So you have bis oxalato nickelate. Nickelate, what does nickelate 2? Here is a neutral molecule. There's a neutral molecule. This 2 is coming from nickel. So nickelate 2. Now with this, we come to the end of our video for coordination compounds. God bless you.